In this video, we'll briefly introduce differential equations. In general, a differential equation is an equation that contains an unknown function and one or more of its derivatives. The order of the differential equation is the order of the highest derivative that occurs in the equation. In this case, the highest derivative is the second derivative, making this a second-order differential equation. There are different ways to represent a differential equation. Instead of writing it like this, we could think of y as a function of x. Then, rewriting this same equation, we would have the second derivative of f minus 3 times the first derivative of f plus 2 times f equals 0. We could also use the Leibniz notation. In that case, we would have the second derivative of y with respect to x minus 3 times the first derivative of y with respect to x plus 2 times y equals 0. All three of these represent the same differential equation, just different ways of writing it. Now, the solution to a differential equation is not just a single number or a set of numbers like we see with algebraic equations. The solution to a differential equation is a function or maybe a class of functions. Let's look at one particular example. One solution to this particular differential equation would be y equals e to the 2x. Let's verify that that is the case. The first derivative of y equals e to the 2x would be 2e to the 2x, and then the second derivative would be 4e to the 2x. Now, thinking about the original differential equation, let's verify that y equals e to the 2x is indeed a solution. We'll just make some substitutions. Replacing the second derivative with 4e to the 2x, then minus 3 times replace y prime with 2e to the 2x, plus 2 times replace y with e to the 2x. And we want to know, is this true? Is this a true statement? 4e to the 2x, negative 3 times 2 is negative 6, e to the 2x, plus 2e to the 2x equals 0. Combining like terms, 4 minus 6 plus 2 is 0. We have 0 equals 0. Since this is a true statement, we know that y equals e to the 2x is a solution to this differential equation. But it's not the only solution. There are a whole class of solutions that are true for this differential equation. We'll investigate this idea more in the next video. In this example, we'll determine if the function is a solution to the given differential equation. Notice that in the differential equation we have y prime. Let's find the derivative of y off to the side. Y equals 1/2 x to the negative 1/2 power. Now plug in what we know into the equation. We have x times y prime we can write as 1/2, and I'll put x, square root of x in the denominator, minus y. We were told that y is the square root of x. And we're asking, is this equal to 0? Let's simplify what we have. 1/2 times x divided by the square root of x minus square root x. Simplifying that, we have 1/2 square root of x minus square root of x. Simplifying once again, we get the square root of x divided by 2, which is not equal to the right side. It's not equal to 0. Since that is not a true statement, we can say that y equals the square root of x is not a solution. But what about y equals 2x? Let's see if this is a solution. We again need the first derivative. The derivative of 2x is 2. And then we'll plug in what we know into the differential equation. X, replace y prime with 2, minus y, we are told is 2x. And we are again asking, is that equal to 0? 2x minus 2x is indeed 0. We get a true statement. The left side equals the right side. So this time we can say that y equals 2x is a solution. Now keep in mind it is one solution. There's an entire class of solutions that is true for this differential equation. We'll look at that in more detail in the next video.